everyone. Good to see you all. For those of you who don't know me, I'll give a brief introduction. So my name is Virginia, and you may have seen my name on emails sent by Pilot Prep. I'm one of the founders of Pilot Prep, and I'll be teaching you all Math 10C this semester alongside Stephanie, who couldn't make it today. So for those of you that started school this week, I hope you had a good time and also stayed safe, especially remembering to wash your hands after coming home. I'm now going to share this PowerPoint. All right. So this week we're going to look at trigonometry. This topic might be completely new to you, or maybe you've heard of it before but don't really know what it means. Trigonometry is first introduced to students in grade 10 math, or at least it is here in Alberta. I'm not sure how it is for other parts of the world. So trigonometry is a super important field in the math universe. You actually will have another trigonometry unit in grade 11 and grade 12 where they just expand on the basics, which is what you're going to be learning today. So just a quick reminder that the lesson is being recorded, so this is why I won't be able to allow your mics to turn on since your voices would also be recorded in the video. If you have any questions, please type it in the chat. And by the way, we do upload recordings of all our lessons on YouTube. If you're not getting them, please email us. Now, before we start, I want to quickly talk about tutorials and how they're going to work. So tutorials are based on request, since it's pretty pointless if we host a tutorial and no one comes. If you would like a tutorial this week, please email us to request one. We'll have an open tutorial where anyone can drop in to ask the tutorial leader for help in math or science or topics that they didn't really understand from the class. It's a lot like talking to your teacher after the lesson. Anyways, we have a lot to get through today, so let's get right into it. First off, what is trigonometry? Well, if you read the slide, it gives you a fancy formal definition, but what it means in simpler terms is essentially triangle math. Math about triangles. An entire field focused on angles, the different sides of triangles, degrees, all of that. So it might seem a bit overwhelming, but don't worry, because in grade 10 we start only looking at right triangles. So if you need a bit of a refresher, right triangles are basically triangles that have one angle that is 90 degrees. And 90 degrees is symbolized by the little square box in that angle. All the other angles are symbolized with a partial circle. So now we're going to introduce some new terms to you. Oh, let me draw on the angles first. We're going to introduce some new terms to you, and we're going to look at all of the sides from the perspective of angle X, which is this one. So the longest side of the right triangle is called the hypotenuse. So if you look over here, this would be the longest side. And you may have already heard this term before if you studied Pythagorean's theorem, you know, a squared plus b squared equals c squared. Okay, so the side opposite of angle X is given a name too. It is called the opposite side. Wow. We're lucky, it's easy to remember. Now the side that's beside angle X, so the last remaining side, is called the adjacent side. Now you might be wondering, wait, aren't there two sides that are touching angle X? Which one is the adjacent? So one of the sides is already named. This one is already called the hypotenuse, which leaves the remaining one, the adjacent. Adjacent is just another word for beside. So let's move on. Now we have a different perspective. We're going to be naming all of the sides of this triangle from angle Y. So first of all, the hypotenuse doesn't change. It's always called the hypotenuse because there is only one side of the triangle that can be the longest. So we're going to name this side the hypotenuse. And now which side is the adjacent? If we look back at the angle, we can see that there are only two sides that are touching angle Y. So one side's already the hypotenuse, which means the other side is the adjacent. Now this leaves the last side, which would be the opposite. And if you look back, you can see that this side is directly opposite of the angle y. Don't worry if I'm moving too fast. These notes will be available in the Google Drive with all the annotations. So now we're going to look at something called trigonometric ratios. The three trigonometric ratios are sine, cosine, and tangent. You may have seen it on a calculator before, where it's often abbreviated as sine, cosine, and tangent, or tan. So sine, cosine, and tan are just means that are given to these ratios. We're going to look at these ratios over here. So first off, we have the sine ratio of an angle. The sine ratio is opposite divided by hypotenuse. Opposite over hypotenuse. Oop. It's often written as O over H for short. And the cosine ratio of the angle is adjacent over hypotenuse. Oh, I'm going to run out of space. I'll just move it over a bit. Adjacent over hypotenuse. This is also written as A over H for short. Now, finally, we do have the tangent. Now, this one's a bit different, but it's just opposite over adjacent. Also known as O over A. Now, with that, we've learned all the basic trigonometric ratios. Now, since this is all new, it might be hard to remember all these ratios at first. That's why a lot of students use the rhyme Sokotoa. I think it's supposed to rhyme with the name of some volcano in Hawaii, but I'm not really sure. Most people don't even know of a volcano called Sokotoa, so it doesn't really matter. Anyways, this abbreviation is supposed to help you remember the trig ratios. SOH is short for sine is equal to opposite over hypotenuse, so sine S, opposite O, hypotenuse H, and ka is just cosine is equal to adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so you might all be wondering, well, learning all these ratios are great, Virginia, but when are we actually going to use them? Well, first of all, you will need these fundamentals in higher level math courses, but I'm going to give you all an example. So say you want to find the height of a tree. The height of a tree we're going to call x. So over here is x. We want to find how tall this tree is. Now what we do know, let's suppose we're standing over here. Hi. We're standing over here and we're looking at the tree, and it's an exact 30 degrees from our view from the top to the bottom. And we're standing exactly 3.1 meters away from the tree. Now we want to find the height of the tree accurate to 2 decimal places. Now with this, we're going to need a calculator. So I'm going to pull up the digital calculator. So over here, I have a graphing calculator. It's, I'll talk more about that later, but we're going to put in our numbers. Oh, another thing to make sure before you use your calculator is that you want to make sure it's actually in degrees. So right now, this calculator is in radians, and radians is basically just another way of measuring angles, but we want to change this to degrees. Now we can put in our numbers. So what we're going to do here is we're looking, essentially this is a right triangle, right? We're looking for the opposite, and we have the adjacent. So if you remember from the last slide, the ratio that uses both opposite and adjacent is a tan. So we're going to use the tan ratio. And we already have the angle that we already have the angle of tan, so we can just put that in. So tan of 30 is equal to opposite, which is x, over the adjacent, which is 3.1 meters. So now with our calculator, we're going to input, sorry, I jumped a bit ahead. We have to first isolate x before we can put anything in our calculator. So much like basic algebra, we're just going to multiply both sides by 3.1 meters times 3.1 meters. It's a bit crowded, which leaves 3.1 meters times tan of 30 degrees is equal to x. Now we can put it in the calculator. So I'm going to put in 3.1 times, by the way, this is what shows up on the screen. If you have a graphing calculator, you can try it out for yourself. So 3.1 times the tan of 30. And we're going to enter. This gives us, oh no, that is not supposed to be, oh yes it is. So this gives us 1.789 blah blah blah, and we want to find it accurate to 2 decimal places. So we're just going to round that up to x is equal to, have to pull it back up, x is equal to 1.79 meters. All right. And over here is just a little bonus question for you to do. Now we have another practice problem. So yeah, we're just going to do the same thing that we did last time, but this time we have to find the angle. We're given the height of the tree and we're given the height from the tree, but we want to find the angle at which we're looking at the tree from. So over here, we're gonna use tan again. Whoops. And since we don't know the angle, we're just gonna call it tan A is equal to the opposite, which is 5 meters, over the adjacent, which is 3.8 meters. Now, you might be thinking we can just input this into our calculator, right? But it's really, really important to note that if you're looking for angles, you will have to use the inverse of tan or cosine or sine, whatever ratio you're using. So the inverse you'll learn a bit more about in grade 12, but basically all you need to know now is that the inverse is the function with a tiny, you can't see it very well from here, but it has a tiny floating -1 on top. So how you access that blue part is you have to press second and then the tan. And over here you can see it. This is the inverse of tan. So now we're going to use the inverse of tan and just put in the numbers. 5 divided by 3.8. We can close off the brackets if you want, but we don't have to because the calculator is smart enough to know. And now we get 52.76. And let's just round this up to the nearest whole degree to make it easier. So this would be 53. That means tan A is equal to 53 degrees, or actually I should say A is equal to 53 degrees. And over here, here's another bonus question. Actually, since we have time, let's just do it. If the distance was 3.1 meters instead, how would this affect the angle? So what this means is that instead of being 3.8, this is 3.1 meters. So we're just going to do the same thing with our tan, except this time, instead of dividing the 5 by 3.8, we're going to divide by 3.1. So let's just pull up our calculator, do the same thing, second tan, 5 divided by 3.1 is equal to 58 degrees. Now you can notice here that the angle actually got a bit bigger, and that makes sense because if it's closer, you can kind of imagine like shifting this side. If it's closer, then the angle would have to be bigger in order to reach the top. Kind of like how if you stand at a building or you stand far from a building, you don't have to look very high to see the top, but if you move closer, you're gonna have to lift your head up a bit more. All right. So over here, we're going to calculate some more angles. So over here, it's really just asking if you had the cosine of 19 degrees, this would be, let's say this would be 19 degrees. So the opposite, the cosine is not opposite. Oh, cosine is adjacent over hypotenuse, which means that the adjacent is this side, the hypotenuse is this side. What this means is that you just want to divide whatever value this is with whatever value this is to get the cosine of 19 degrees. Over here we have the same thing, cosine of 89 degrees. So let's name this side 89. Ooh, it's getting a bit crowded. 89 degrees, and since sine is opposite over hypotenuse, we're going to divide whatever the opposite is. So the opposite in this case is this side with the hypotenuse. And lastly, we're going to have the tan of 45. So we have 45 degrees over here. We just want to find the tangent of it. So that would be opposite over adjacent, which is whatever value this is, divided by whatever value this is. All right, moving on. Yes, now we're going to look at some angles. So we're going to start off with the sine of m, which is this angle. We want to find out what this angle is. So what we do is we use the sine ratio. The sine ratio, if you remember, is opposite over hypotenuse. Now this time we actually have numbers to input. So the opposite is 6 centimeters, and the hypotenuse is 10 centimeters. I'm not going to put the units because I'm running out of space, but if you were ever writing a test, your teacher would very, very likely want you to put units down. So what we're going to do here is grab our trusty calculator once again and put in second sine. Remember, I'm using the inverse because I'm looking for the angle of 6 divided by 10. And we get 36 point blah, blah, blah degrees. Let's round it up to the nearest degree, 37 degree. So this is 37 degrees. Next, we want to find the cosine of, we want to find angle n using the cosine ratio. So angle n is over here. The cosine ratio is adjacent over hypotenuse, which is just the adjacent angle, which is 6 centimeters, divided by the hypotenuse, which is 10 centimeters. Now notice how these numbers are exactly the same as the numbers that we had before, but we're going to get a different answer, and that is because we're using a completely different trig ratio. So let's pull up our handy dandy calculator again, put in a second cosine of 6 divided by 10. And we get 53 degrees. Let's just label it, this angle is 53 degrees. Lastly, we're going to find the tangent of m. M is over here. We already know the angle. We already know what the angle is, but we just want to practice using tangent ratios. Oh, forgot to label this as 90 degrees. So what we're going to do is use the tan ratio, which is opposite over adjacent, which in this case is the opposite, 6 centimeters, over the adjacent, 8 centimeters. So we're going to come to this, we're going to be coming to the same answer using two different methods. Let's grab our calculator again. Second tan of 6 divided by 8. And yes, we do get the same answer, 37 degrees. All right. There will be lots of practice questions like these in the workbook, so if you want to do a few more of them, go ahead. So now we're going to calculate some even more angles, except this time the angle ratio has already been given to us. So all we have to do is just input the numbers into the calculator. We're going to go the second cosine. Remember, we always have to use the inverse when we're looking for the angle. Equal to 0.4921. This is equal to 60.5 degrees. So let's just round it up to 61 degrees. So, yeah, we're really lucky to actually get calculators that are this advanced, because before the age of calculators, maybe you can ask your parents or grandparents, when they needed to evaluate a trig ratio, they actually had to flip through a little book that had all the ratios of every triangle, kind of like looking in a dictionary. So that's a fun fact for you. Next, we have the cosine of theta. By the way, this little symbol over here is theta. It's a Greek letter. We use it a lot for angles. We just want to find the cosine of angle of 0.8779, which is 28.6. So let's go 29 degrees. And finally, we have the sine of beta. This is beta, another Greek letter. It's pretty famous. You've probably heard of it. We're going to go back to the calculator. Second sine of 3 divided by 4. Since we have a bit of extra learning, let's put this in a function that, or in a ratio that's probably familiar with you. So looking at this imaginary triangle, if you remember that sine is opposite over hypotenuse, you would know that this is the length of the opposite side, and this is the length of the hypotenuse side. So we can actually, just looking from this formula, or just from this equation, construct a mini right triangle. We know that the hypotenuse is 4, and the opposite is 3. So now we want to find out what this angle is. Let's grab our calculator again. The second, oh, I already put it in. Let's just calculate then. Whoops. Second sine of 3 over 4, opposite over hypotenuse, is equal to 48 degrees. All right. Let's move on. Now we're going to calculate x. We're going to do some calculations for each triangle. We want to find the missing angle x, the value of x. So it's a lot like the tree ones, or all the other calculations that we did earlier. So right now we want to find angle x, right? And we have two values that are given to us. One is the hypotenuse, which is 52, and one is the adjacent. So using these two numbers, which trig ratio can we use to find x? Well, SOHCAHTOA, so ka has both the adjacent and the hypotenuse, so we can use the cosine. So we're going to find the cosine of x, which is 34 centimeters, but I'm not going to write the units because I'm running out of space, over 52 centimeters. I'm just going to do all the calculations in one go, so let's finish the second triangle first before we pull out the calculator. Over here, this is a bit different. Instead of finding the angle, we're going to look for the side. So over here, we're given this angle, and we want to find what x is. So relative to 62 degrees, x is the hypotenuse, and 10 is the adjacent. Ooh, capital, adjacent. That was messy. So using this formula, we can once again use cosine. The cosine of, I'm gonna need to write it higher because we have to do some isolating of x here. Cosine of 62 degrees is equal to the adjacent 10 over the hypotenuse. Now over here, you might just think, oh, can I just multiply by 10 on both sides to get rid of the 10? Unfortunately, that doesn't work because if you do multiply it by 10, it will actually become 10 squared. So I'll put it down for you in this format to help you kind of better remember. Do you agree that 10 over 1 is the same as 10? So if you tried multiplying both sides by 10, you would actually only get 10 times 10 and x times 1, which wouldn't get rid of the 10 at all. It would actually square it, making an even bigger problem for you. So we don't want to do that. What we want to do is actually, multiply both sides. Oh, this symbol over here is just a multiplication sign, a dot. We want to multiply both sides by x to get it over here first. So now we have, cross this out. We have x times the cosine of 62 degrees is equal to 10. Now this is a bit more manageable. You can just divide both sides by the cosine of 62 degrees, which will give you, cancel those, x is equal to 10 over the cosine of 62 degrees. Now we can put these in our calculator. So let's grab it. Let's start with the triangle on the left. So over here we have cosine x is equal to 34 divided by 52. So I'm just going to put it in second cosine. Since we're finding the angle, we have to use the inverse, which is why I'm putting second cosine. We're going to put second cosine is equal to 34 divided by 52. And that's equal to 49.1. Let's just round it down to 49. On the right, we have x is equal to 10 over cosine of 62. So what we can do here, we don't need to put in the inverse of cosine or anything. We just need to put in this side of the equation into our calculator. So I'm going to do 10 divided by the cosine of 62. We can put a bracket if we want. We don't have to. But it just makes it look more complete. And that is 21.3, and that is the side of the hypotenuse. All right, moving on. Now we are going to solve some triangles. So solving triangles just basically means you need to know all of the angles. So all of the angles and all of the sides of the triangle. So let's name this side x, let's name this side beta, let's name this side beta. This side is already known, it's 90 degrees since it's a right triangle, so we don't need to solve for that. Let's start. So let's just start with beta, just for fun. If we look at angle beta, we can see that the two values that were given to us are the adjacent and the hypotenuse of angle beta. So what we can do is just use the cosine ratio. The cosine of beta is equal to 13.7 centimeters over 17 centimeters. That will give us cosine 13.7 divided by 17. 36.3 blah 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 degrees. Let's just round it up to 36. Cosine beta is equal to 36 degrees. Now let's do cosine beta. Now over here there are actually two ways of solving it now. Since we know both of these angles, we can actually just subtract them both from 180 degrees, since we remember that a triangle, the sum of all angles in the triangle add up to 180 degrees. So we can just do 180 minus 90 minus 36, which will give us angle theta. Or we can do trigonometric ratios. We can use the opposite, we can use sine to figure out angle theta. So let's try that since this is a trigonometry unit. So the sine of theta is equal to the opposite, which is 13.7 centimeters over 17 centimeters. This will give us sine 13.7 divided by 17. This will be 53.6, so 54 degrees. Sine theta equal to 54 degrees. I know this is a bit messy, but don't worry, we'll clean it up for you guys before we post it. Now all that's left to do is solve for x. So x is, the two values that we were given were 17 and 13.7. Now, once again, there are actually two ways of solving this. One is with the trigonometric ratios, and another is with the Pythagorean theorem. So in the Pythagorean theorem, what you would do is basically just remember that a squared plus b squared is equal to c squared. So you just find b, and then yeah. But since this is once again a trigonometry course, we want to use trigonometry to solve. So what we're going to do is use let's use one of the angles as reference. So let's just choose angle B just for fun. What we're going to do is use angle B, and from the view of angle B, x is the opposite. And let's pick another value, so 17, or let's use 13.7. 13.7 is the adjacent. So using these two values, x and 13.7, we can find x. Since we already know two values, we can always find the third. So we're going to use tangent, since opposite over adjacent is the tangent ratio. Tan of x is equal to opposite. Oops, sorry. So the tan of 36 degrees is equal to x over 13.7. Remember, opposite is x, adjacent is 13.7, so this is the tangent ratio. Now we can't just put this into our calculator. We first have to isolate x. So what we do is we can just multiply both sides by 13.7. That will give us 13.7 times tan of 36. And now we can put it in our calculator. Of 36 times 13.7. Now, before you put in the 13.7, it's really important to remember that you actually have to close off the bracket before you put in the times 13.7. If you don't, like if you just put it in like this, what the calculator is going to read this as is just the tan of whatever 36 times 13.7 is, which is not what you're looking for. You actually do have to put in a bracket after the tan. So tan of 36 bracket times 13. That gives us 9.95. So let's just round that up to 10. X is equal to 10 cm. All right. This other triangle is a bonus one. You can do it on your own. Now we're going to look at something called angles of elevation and depression. So in real world problems, it's common to call these angles, or call angles as angles of depression and angles of elevation. Now we're going to look at these. So basically what an angle of elevation is say that you are looking at an object up high. So this would be the ground, and this is your line of sight. And here's you. You. Yay. What you're going to do, this angle over here, it would be called the angle of elevation. So imagine your head is tilting up, so your head is elevating towards the sky, so that's why it's called the angle of elevation. Now over here, we actually have the opposite. So here's you again, now you're on an air balloon. You are looking down. So how this works is, let's say first you looked at a straight line, a line that is parallel to the ground, parallel. So from this parallel line, you would tilt your head down and look towards whatever this is. This angle over here is called the angle of depression. So just imagine that when you look down, it might be because you're feeling a bit depressed or sad, so you kind of let your head droop a bit to look down. I hope that helps. Anyways, you'll be doing a lot of these problems at school anyway, so I'm sure you'll remember them. So now over here, we're going to have a mini word problem. Actually, it's quite complicated. It might take us a while. So over here, we have 3 hot air balloons. So over here, we have some important information. Let's just underline all the key information. So the horizontal distances between the balloons from left to right are 25 meters, 15 meters, and 15 meters. Oh. So the pilot of sunset, which is this, is at an altitude of 75 meters. So what this means is that from the pilot all the way to the ground is 80 meters. Oh, sorry. I think I read that wrong. Did I say 80 meters? 80 meters. Now the pilot of pastel is at an altitude of 75 meters. So it's just 5 meters lower than sunset. I'm going to put in 75. It's important to label all of this information because it helps you kind of visualize it better. And finally, the pilot of blue is at an altitude of 60 meters. All right, if you want to copy this down and do it along, go ahead, I'll give you a bit of time. Okay, so we do have one more key piece of information that we didn't look at yet. The horizontal distances from the balloons from left to right are 25 and 15. Okay, so what this means is that from left to right, so from sunset to blue, the horizontal distance is 25 meters. And from blue to pastel, the distance is 15 meters. So now that we've labeled all of the key information from the word problem, we're going to look at the questions that they're asking us. So what is the angle of depression as sunset looks at blue? Sunset is over here, blue is over here. So the angle of depression, let's just first draw a straight line. This is the horizontal line. We're going to go down and stare directly at blue. So we want to find this angle. Let's call this angle theta. Now what we do here, a lot of people, what they commonly mistake is that they actually find this angle instead. Now this angle is actually not the angle of depression, because remember, the angle of depression is the angle that you form when you look first straight and then down, like you tilt your head down. So we actually have to look for this angle, not this angle. This is the wrong angle. So from the information that we have, there are a few ways that we can solve this. So firstly, we can find this angle. Oh, I shouldn't have crossed it out then. Oops. We can find this angle and then subtract this value from 90 degrees because we know that this makes a perfect rectangle. And from this, if we do solve it, let's first take a look. So from this angle, let's try to solve this. We have 25, which according to this angle is its opposite. This is the opposite. And we have 80, which is the adjacent. So from opposite and adjacent, which ratio are you going to use to solve this? Well, you would most likely use tan. Actually, you have to use tan. There's no other. Let's give this a name too. Let's call it alpha, angle A. Tan of angle A is equal to the opposite, which is 25, divided by the adjacent. So let's plug this into our calculator. You can hear the calculator noises. Don't forget to use the inverse because we are looking for an angle. 25 over 80 is 17.35. So this is actually really, really out of scale. A is equal to 17.3, blah, blah, blah. Now what's really important is that we don't round off this value yet because this is not our final answer. Our final answer is theta. We want to look for theta. So in order to do this, we would have to subtract whatever A is from 90. So 90 minus A, this is kind of a bad A. 90 minus A is equal to theta. I'm going to move this up here so there's more room. Theta is equal to 90 minus 17.35, 72.64. Let's just round it up to the nearest whole. 73 degrees. That is the angle for answer A. Equals 73 degrees. For the rest of them, I'll let you look at them and give you a bit of time to solve. We are going to, oh, this is quite messy. I'll have to erase it all to solve the rest of them. Boop, 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 boop. I'll let you take a look at this. I'll give you a few minutes. Actually, we might run out of time, so maybe not. Yeah, don't worry if you want more practice and you aren't getting any from this PowerPoint. We will have lots and lots of worksheets or problems on the worksheet. Okay. Oop, oop. All right, question B. Now we want to find the angle of elevation. Pilot looks at the sunset pilot. So this would be this elevation. Whoop. This is quite messy, but remember we're going to look at it from a line that's parallel to the ground and look up. So essentially what we're all drawing here are a bunch of right triangles. These are just a lot of right triangle questions. We want to find this. And let's call this angle X just for fun. From this information, it might look as if we don't have enough information to find out what X is, but we do have a lot of information in the form of all of these values. Whoa! So what we have at the bottom, if we remember from earlier, is that the horizontal distances from the balloons left to right are 25 plus 15. So what this means, 25 plus 15, is that this entire horizontal length would be 25 meters plus 15 meters. And that would be, hopefully you don't need to grab a calculator. Oops, I drew a plus sign. Equal to 40 meters. So this 40 meters is the length of the adjacent of X. What other information we have is we don't have the length of a hypotenuse, but we can calculate the length of the opposite. So what we can do here is remember that the elevation that sunset is on is 80 and the elevation that pastel is on is 75. That means there's a difference of 5 meters because 85 minus 75 is equal to 5. There's a difference of 5 meters between their altitudes. So the opposite side is 5. Now we have two values that we can calculate X from. Which ratio should we use to actually find X? Well, since we have the opposite and the adjacent, we'll have to use tan. Tan of X is equal to 5 over 40 meters, of course. Now we just grab a calculator again. 5. The second tan, the inverse of tan, of 5 divided by 40 is 7.12, blah, blah, blah. Let's just round that up to 7 degrees. I mean, this answer is X is equal to 7 degrees. Don't forget units. Teachers will deduct marks for units, missing units. So whether it's meters, centimeters, degrees, you'll have to put it in. Or else they won't know what the numbers are for, right? Okay, now question C. You're standing on the ground directly below sunset. What is your angle of elevation as you look at the pastel pilot? Okay, so this is really not to scale, but let's say that the ground is here, completely out of scale, yep. And you are standing here. Now you are looking directly at the pastel pilot, which means that we can form a right triangle just like this. Wow, this is really, really messy. I'm gonna have to clean it up a bit. Whoop, whoop, whoop. All right, hopefully this looks a bit better. I'm gonna bring my pen in. Well, let's choose a different color since we've been using blue this entire time. Let's go orange. Now we can form a right triangle with our angle of elevation. So over here, I'm gonna just state that it's a right triangle by drawing a little box in the corner with the 90 degrees. What we're looking for here is the angle of elevation, right? So let's name this Y, angle Y. Now, we already know that the horizontal length, right? It was 25 plus 15, which we calculated earlier. 25 plus 15 is 40 meters. So I'm just gonna label this. And then we also over here conveniently know the height, since the altitude of the pastel pilot was given to us. It is 75 meters. So from these two values, we have enough information to calculate the value of Y. Now, from the perspective of Y, 75 is its opposite side and 40 is its adjacent side. So once again, we have opposite and adjacent, which means we're going to use tan. 75 meters over 40. Now I'm going to grab my calculator. Second tan is equal to 75 divided by 40, which is 61. Y is equal to 61. Oh, 61.9. That means we have to round it up to 62. Whoops. .62 degrees. Wow, this is 62 degrees. And with that, we have answered all these questions. It looks like it's gonna be the last. Yeah, so thank you so much for attending today's class. I will stop recording now, so you may speak if you would like. If you have any questions, whether it's